Everyone, thanks for joining the Road to Six-Figure Data Science Job with Richard. We're on episode 4. So last video, we went over A/B testing interview question. We also looked at the solution for when Richard solved the SQL question that was more of a medium to hard. We realized that Richard needs to work more on his case study skills. Currently, he's going over the introduction to A/B testing learning path on interview query. And then his assignment for last week was to also work on formulating the solution that we went over in the A/B testing question into an actual written solution online. So today, Richard, let's go over that solution and then see how you did and see if we can actually add to it anymore.
Sure, sounds good. Okay, so just to recap this question, it was a question about banner ad success for an online media company. The media company is starting to monetize its web traffic and wants to experiment with adding web banners into the middle of reading content to see if it could monetize effectively. Last week, I did have a little bit of trouble going through the case study framework, clarifying the question, defining goals, and define the experiment. And really writing up this question made me think about case studies in a more cohesive way to form a narrative to kind of tell the interviewer. So we start by clarifying the question. What exactly are we testing in the experiment? So adding web banners to the middle of the web reading content. We want to set up this experiment with and without ads. So last week, we did talk about 3 different variants of this test. So the control variant to measure the baseline of the web page without any ads, and then variant 1 with 1 ad, and then variant 2 with 2 or more ads to see the effect of the ads on a user's time spent on the website, their repeat visits, and most importantly, the revenue generated by each user. Going through the A/B testing learning path on interview query, there are a couple of things that I was a little confused by. So first of all, the length of time that this experiment runs for has a pretty big effect on the experiment and the number of times you test the significance of the results. Testing more can have a larger chance of seeing a significant effect. So I'm a little bit fuzzy on these kind of concepts, but the basics of this experiment would be to test these 3 variants over, say, a 2-month time period and split up these users into equally distributed and equally sized user groups that are randomly distributed. We don't want to see users coming from one type of attribution channel more than the others. So we want to make sure that the population is randomly distributed between these groups. And then after running this experiment for 2 months, we can measure a couple of things: the time spent on the website, the amount of visits that they visit the website over time, and then also the revenue that generated by the web ads, like the amount of times these ads are shown, their click-through rate, etc. And we could use statistical tests such as the t-test to test for whether or not these results were significant between these different buckets. And then we could use those results to kind of drive the decision on how many ads to show on the website and what the change was from the baseline.
Nice. Okay. I think you did a good job of kind of like creating that overview of what we talked about in the last episode. That first level of completion for an A/B testing or a case study is just to kind of summarize the general experiment landscape, right? And then once you start getting to higher and higher levels of analysis and understanding within data science and data analytics, you start diving into like the other aspects of this question, which could be basically adding more factors into it, right? Because right now we're just saying like, oh, we'll just measure the revenue results between the different variants, right? But that's pretty hand-wavy in terms of like what actually happens when you measure revenue results, right? Like we have to look at click-through rate. We have to look at if the customers purchase through the actual ads. And what if there's some ads where customers purchase a lot and other ads where they don't purchase a lot? And what if they were oversampled in one variant versus another, right? That would create weird discrepancies in our A/B testing. So like you said before, kind of like also you're a little confused about the statistical tests and basically the length of the experiment. A lot of that comes with experience, but a lot of these are also kind of hard set numbers that people kind of just give frameworks for. So they're not really preset, but they're more like generally we do like 2 weeks for a test, or generally we need this many users. And then generally we only run the experiment and analyze the results once, because if we do it multiple times, right, over the course of the preset period, then we're going to get different results potentially. So overall, this is a good first step, and we can start moving on to another question. We'll come back to A/B testing and kind of case studies again in the future, but I think this is a good step for you to kind of start practicing more questions around the same level, and we're just completing the A/B testing learning path. How far are you in the A/B testing learning path?
So far I completed kind of the introduction to it. I'm about 17% of the way through. I did the introduction and read through the A/B testing and experiment design. For the statistics part of it, the hypothesis testing, confidence interview, I'm still kind of working through that. I think the trickier parts will be to go through the common scenarios for A/B testing and the trade-offs and making the decisions, seeing what kind of variables I could control in the experiment. So that, along with the statistics part, I think that's what I still need to work on.
Gotcha. Yeah. A/B testing can also be like sometimes even the trickiest or the easiest part in an interview. It's the trickiest because a lot of the times as a new grad or someone who doesn't have any industry experience, you have no prior experience running A/B tests yourself. So there's basically no prior in your own experience in terms of being able to talk about it and be able to use that knowledge to essentially answer the question effectively, right? You can't really draw any past experience. On the other hand, there's been so many case studies and so much kind of this knowledge on the internet where you can take these courses like on Interview Query and on other websites where they basically tell you the exact frameworks for how to tackle each A/B testing question given like these parameters. So like, what do you do when it's a split test with 2 variables, or what do you do when it's with 3 variables, or what happens when it's like a front end website change, or what happens when it's like a user tied test versus a session tied test, right? All this stuff kind of exists. It's out there and you can read up on it and you can see what the common kind of solutions for are. And so then it becomes more of a practice of like kind of memorizing these different areas and these different kinds of case studies. So then you can apply it to the questions that come up on the interview and also for real life, case studies that happen when you're running experiments on the job. There's definitely a trade-off to that. It kind of depends on, what kind of person you are in terms of how you feel good about an interview, whether you can just kind of do the work and kind of really learn the concepts, or if you feel like you need to like fundamentally run an A/B test yourself for you to like intrinsically understand the material, right? And apply it to your interview. That's kind of what I want to wrap up on A/B testing.
Yeah, that definitely makes sense. I mean, all the material, all the content I go through, there's a lot of theory behind it, a lot of best practices and frameworks, but I think really the best teacher is experience. And going through a couple of these A/B testing assignments myself and thinking through and maybe even performing a couple, I think that would probably be where I learn the most out of this content.
Cool. All right. So let's move on to the next question in our span of interview questions. And today we're going to tackle a Python interview question. So I think we have one set up already. So Richard, if you can share your screen and move to that question, let's go through it. This question is on recurring character. So as you can see, you can read off the question here, but given a string, write a function called recurring char to find its first recurring character. Return none if there is no recurring character. And then it says treat upper and lowercase letters as distinct characters. You assume the input stream includes no spaces. So for the example, we have interview query. Output is I, right? Because I gets repeated as the first one because it shows up in the very beginning. And then by, character 7, it's essentially repeated as I. So Richard, how would you tackle this question?
So it seems like we have to iterate through every character in the input string. And for each character, you have to test if it reoccurs. So I think that we need some kind of temporary variable to hold the first character and compare it to the next character and see if it recurs. That's what I'm thinking to start. So let's see. I would start with a temporary character. Let's assign it to none to initialize it, or to an empty string, I mean. And then I would do something like for character in input. So I'm wondering if we have to iterate through this for every character in the string, right? So you have to look at I and then compare it to the rest of the string. And then N, you have to look at, hold that in temporary and then compare it to the rest of the string until we get the next match. If we get the match, then we return the character. So I think we have to use a nested for loop here. So I would say for character in input, temp is car character. And then to get the rest of the string, now we have to iterate through the whole string again. So we could do, so this probably isn't a very efficient way of writing this. I'm sure there might be a better way of doing this, but this is what I'm thinking for now. So we go through it again. Say if temp probably initializes to none because this is asking for none as output if nothing's there. And then if it goes through both loops, then we can return whatever's in there, which is none. This is what I'm thinking. Let's see if this works.
Okay. Not look like it worked.
I'm going to put a couple of print statements. Let's see what's going on. So let's see what's in input for this test case. Okay, so it goes through y, capital Y in input, temp equals y, and then again, so it's going through the whole string again. So it's going to say, of course, y equals y because it sees it already. So I have to somehow slice the string.
So what are you trying to do with this, right? So basically you're going through the first input, so it's y, and then you're going through the whole thing again, and you're like y equals y, so you return y. That's what you're saying, right?
Yes,
so
exactly.
That obviously is not the correct way. Let's start over a little bit and think about how you would do this by hand normally. So that's something that helps me when I'm solving algorithm type coding questions is like, how would I do this by hand if I was a computer?
My first thought is I would take the first letter and then compare it with the rest of the string. So for each iteration, I think I need a substring that is like without the first characters.
And so do this. So can you say that out loud specifically for our example input here? So you look at I, and then you look at the rest of the list and be like, where does I show up?
Right. So I would take I into temporary and store that and then compare I with interview query.
Okay, but what if there was an N on the second letter and then an N at the fourth letter? Then if you compared I and then you were like, oh, there's another I in here, that's right, it'd actually be wrong, right? Because there'd be two N's in between the I's. So your method wouldn't actually work.
Right, because that won't be the first recurring characters.
Yeah. So your fundamental pseudocode method and the way that you're thinking about it is actually wrong. So I gave you that edge case, right? So now how would you solve it for that edge case?
So it seems to me that you'd have to have this temporary character stored for every character in the string, like every first instance of the character. So you would take I and compare it to interview query, and then N, and then compare it to the rest of the string. And then whenever it matches first, you return it.
What do you mean whenever it matches first? Because you said I compared to the rest of the string. Okay, so you do I, you compare to the rest of the string, you found a match.
Right, and then the next loop would be if I or N is in the rest of the substring.
Okay, but then you have to go through the whole string, right? So then let's say I do N, I'm like, oh, I found a match as well. Now what? Do I go to T? And I'm like, okay, time to find another match.
No, if it matches, then you return.
No, I thought you just said that if you have I and then you go through the rest of it and you return an I, then you return it, but that's not correct. So let's spell out this new word that we're trying to do as the input. So let's do like INTEN.
Okay.
So like, let's just work through this individually. Input equals INTENRV intern view query, maybe. That's funny. That's you right now, the intern view query, the data science intern view query. Let's go through this, right? So you get a match back at the 8th character, let's say, right? And you get a match back at the 6th character, right? Okay, so how would you create a logical sequence for this that would make sense? Would you go through T and you're like, okay, now it's T. What if I get a match at the 5th one for T? Then I should return T at some point, right? But then I could still keep on looking at E. So to me, this isn't a very good efficient algorithm. Now, I'll tell you what I would do if I were doing this problem, right? Like I would probably just like remember the letters that came before it. So I'd be like, I, okay, if the next letter is an I, then I can return an I because I have an I in the set. Okay, IN. Okay, if either an I or an N shows up, whichever one that shows up first, next after this, I'll return that one. Okay, INT. All right, now I got 3 letters that I got to think about in the future characters of the string. All right, IT, INTE. All right, now I got 4 letters that I got to think about in the future if any of them show up. Same with R. Now I got 5, and then N shows up. All right, N. I found a match within N and the past 5 letters. N is in those past 5 letters. Therefore, I return the N. Does that make sense?
It makes sense.
Yeah.
What is kind of fuzzy to me is how do we store like an increasing number of characters and iterate through each character in the first string and second string?
Well, I'm not sure how much algorithms you've taken, but when you want to store things in memory, what do we use?
Variable?
Yes, everything is a variable technically, right? But let's say we want to store multiple things, right?
A
Have you taken
list?
algorithms yet? Data structures and algorithms?
I have had experience in like the general CS classes, but I
Yeah,
haven't
yeah, yeah.
taken like a
Your general
specific.
CS class, exactly. What did we use? Different structures, right? Just start naming them. We have a list. We
Yeah, I would
have trees. We have linked lists. What else do we have?
tuples, dictionaries,
Okay. Dictionaries. What does a dictionary do?
strings. A dictionary keeps counts of, or it has keys and values that you could store
Okay,
in
but
its
you just
data
said it
structure.
keeps counts, right?
Okay, so yes, we could
So
use it.
yeah, how can we use a dictionary here?
That's a great hint. So we could probably use a dictionary if it exists inside the dictionary's keys. We could add it as a key and initialize a count equals to 1. And then if any count equals 2, then we could return it.
Nice. Okay, let's write that.
Thank you for the hint. There, I think this will work.
All right, let's try it.
Yes, that was a good
Okay.
point. I just
Okay.
forgot about dictionaries for
All right, try submitting your
fun mode.
solution too to see if it really works.
Yes, yes.
All right. So what's the runtime of this?
It would be O of n because it has to iterate through every character and input one time at least.
Yes, at least one time. Yeah. Okay. Cool. Yeah, I think this looks good. I'm gonna say from optimally, you'd probably use a set in Python. If you know what that data structure is, basically it's like a list, but instead it keeps unique values. So you wouldn't have to recheck to see if it exists. All you have to do is check to see if it's in the set. And then because the set is already memory efficient, it will return yes or no if this character exists.
So you do like temp equals set input and get the unique characters of input.
Yeah, so
Then
basically all you do is you add it to the set if it doesn't exist in the set, and then you always check to see if it exists in the set. If it does exist in the set, then we return.
I see.
I would also say, in that first if else loop on the for, like if the char is in the temp.keys, why don't we just return the character then? Because that would be the first one, recurring character.
So if it's in temp.keys, return else initialize it.
Yeah.
Is that what you're saying?
And then you don't really have to check it again for like if it equals 2.
All this.
Well, you don't want to return yet. Yeah, exactly. There you go. All right, easy. So what did you think about this question, Richard?
I think I always try to brute force it on the first go, but I think thinking about the different data structures that exist in coding in Python and how to utilize these data structures really can lead to a more efficient and optimal solution. I obviously know how to use dictionaries and sets and stuff, but applying it in this context probably just takes a little more practice when going through more of these problems.
Yeah, I would say your one key mistake was that your brute force solution was not the correct solution. And you usually want your brute force solution to be the correct solution, right? Because it's the one that initially you think of. And so it has to pass the edge cases. So having multiple different edge cases that you think about when you're looking at these examples, as you can see, there was a second example here. So probably looking at that would have helped. So then again, just doing more problems is usually the best way to get good at Python and these kinds of algorithms type questions. By just continuing to practice, you're going to be well set and ready to go. So awesome. Lastly, for this mentorship section, we wanted to dive into like a topic of interest as well, like talking about the data science job market or any questions that you have generally as you're preparing for becoming a data scientist. Do you have anything that you want to talk about, Richard?
Yeah, so as you might know, I'm currently studying for a master's program in analytics, and a lot of the classes do deep dives into the math behind a certain machine learning algorithm or visualization techniques on web pages or something. And I just want to know, do my grades even matter for these classes? And understanding the background math behind some of these algorithms, how important is that? And how often will I apply this in an actual real life job in the future?
Yeah, great question. So I think there's two questions there. One was like, if your grades actually matter, are you talking about that in terms of like getting a job after graduation, in terms of like your GPA, or are you talking about like how hard you should work on this assignment, sort of a thing?
I would say more in terms of getting a job. I mean, I think I should always work hard on what I do, but even if I don't get the right answer to a problem and I learn a lot from it, I think that's still valuable. But the actual grades part in terms of getting a job or the opportunities that will present to me in the future, that aspect of it is what I'm most curious about.
Yeah, so in my experience, I feel like grades have mattered less and less, especially when you're looking at industry roles. Like maybe if you're a new grad, which you aren't technically, and you're trying to get that internship, then it matters. We're slowly moving to a market where we care more about prior work experience, especially for data science rather than grades. I would say like as long as you don't fail your classes, at least you're in the top 50%, top 60%, then grades don't really matter at that point because the differentiating feature between like a top 5% student and like top 60% student in terms of GPA doesn't really matter versus if the top 60% student had like a better internship than the top 5% student, then I would consider that like a better indication of getting a job. That's how I would weight those factors. And to answer your second question about does the theory matter for data science? This is also like a yes and no question. And it really depends on kind of what role you want to jump into and what kind of data scientist you want to be. If you need to do something where you need to dive into the inner workings of a model to improve it, let's say, then you need to know how random forest works and how to improve it. Then technically, yes, I think it does matter to like understand that theory about how it works. I think it also always generally helps with data science because it helps unlock other things that you can do on the job. But if we're thinking about like practical business decision making, let's say, and we then kind of encapsulate a lot of the technical details into something that doesn't really matter as much, we can do more things where we could say like, all right, I know that I can achieve fundamentally a 95% accuracy on this model in some way, like some other person can figure it out, or I can eventually figure it out on my own, right? Like I'm understanding the limitations of it. But if I get a 95% accuracy, how does that improve the business versus getting like a 97% accuracy? While it's important, I would say that a lot of businesses and data scientists can function without entirely knowing and remembering the underlying theory for that if they want to work within those roles. Now, if your job is to, let's say, improve the accuracy of a random forest model by 2 or 3%, then yes, then you have to know the underlying theory, right? Because then you're literally working there. But if it's not really your job to do that thing, then you're working in a completely different kind of scope. And so I'd say most of the time, generally, yes, it's really important to learn the theory behind it. I think in academia, they actually kind of like force it into you by giving you assignments where you have to rebuild things from scratch. You have to understand how these things work. And a lot of companies value that. And they actually ask those as interview questions, right? Because they really care about having like these kind of like pure data scientists that understands these concepts. But at other times, it doesn't really matter as much. And in short form, it kind of depends on what kind of company and what kind of role you're looking for here. Because if you're also just doing a lot of data analysis, then, you don't really need to know a lot of the theory behind that stuff. You need to know like and understand like it from first principles perspective, which is helpful, but it doesn't directly relate to, let's say, applying it. So I think your question is actually pretty common for like most of academia. Most of it is like you struggling through things and proving that you can work hard on things, and then they hire you to work on something completely different. And that happens to every single job. And I think for data science, it's very similar.
Yeah, that makes sense. What I'm getting from this is depends on your role. And for me, I think really learning to bring the most value to my company, whether or not that's like an initial like first pass at a 95% efficiency rather, and then considering the value you get out of the extra 2 or 3% accuracy out of your model, the value between those two is very different. And like you said, the role that I'm actually in really matters depending on whether I'm like a machine learning focused role or just applying first pass data science principles to a certain business case.
Yeah, yeah. I feel like I always kind of get into this moat where it's like, it doesn't really matter as much, like do the practical stuff first. But I would say that it does help with understanding newer and newer things, especially with a lot of this generative AI stuff, right? Like a lot of people don't know how it works fundamentally under the hood. And understanding that from first principles, from the very bottoms up of like data science is helpful because it does give you like more knowledge in terms of where you can apply it to like where it's going to work really well and where it might not work really well. And it might save you a lot of time in that sense versus treating it like a black box and being like, wow, this thing like works really well at this thing, but it lies to me at this. I wonder why that's the case. Well, if you knew the underlying algorithm and why it does that, and you know that it's just kind of trying to predict the next word, then you would understand that feature about it. Right. I personally, initially in my career, leaned on more of like I don't really care about applying the theory stuff. But then as I've pursued further, I've cared a little bit more about like the underlying theory of things and understanding it truly for jumping in there. I don't think I really need to like do an entire assignment about like recreating this thing from scratch, which is what happens in academia when they give you homework assignments. I can just read it, just be like thinking about it and be like, okay, I think I understand this. Let me see if I can read something more complex then and apply my knowledge there versus like going in and like doing it and doing all the practice and like writing out the code and struggling through it. Because I think that they do that for you because you're learning it for the first time, sort of a thing. And then afterwards, it gets a lot easier to kind of build up on that knowledge. But yeah, academia is academia. So they're going to do that no matter what anyway.
Yeah, that's exactly what my assignments are right now. Building a k-means algorithm from scratch or doing PCA just based on, linear algebra principles rather than calling a scikit-learn package function and just doing it in 2 lines. So I have definitely struggled a lot this semester understanding, the value you get between deep diving and just kind of understanding and really learning to learn new things. I think that kind of insight is pretty valuable.
And generally, people that aren't in academia or master's programs, like they can do that if that helps them really understand and learn it fundamentally. But personally, I'm lazy. So I'm just going to go read PCA. I'm going to like, okay, what does PCA do? Okay, this is how it works. Okay, I get it. Like, that's cool. Like, let me see if I can, apply this to something else now. And that's how we learn most things, I would say. But because you're doing this master's program, you got to practice it. You got to like work on it. And yeah, that's just how it is. And that's not bad. And I think a lot of people like that way of learning things. But for people that need to move faster, then obviously, that's harder to do. But you're in school, so that's the kind of game that you're playing right now. Great question. And I'm glad we kind of tackled that. So for next week, I believe what we're going to have you do probably is to practice a few more of these Python questions. And then I believe we're going to go back into case studies and we're going to choose another case study question to go over and potentially tackle another topic that might help you out as we're wrapping up this first few months of kind of preparation. I mean, you're still not really in the job search phase, so we'll keep on doing the building your skills route, but let's continue to kind of get you to practice questions, do the learning paths, and then slowly talk more and more about topics that are related to the job search and finding a job so that we can be prepared probably in a few months for you to start like the actual job search portion of it.
Looking forward to it.
Great. See you later, Richard.
Yeah, see you.